Our goal for this section 2.7, the x factor, is that we can factor trinomials with a equals 1. And what that means is, if you remember looking at equations, quadratic equations in standard form, they are given in the form of ax squared plus bx plus c. So we are looking at trinomials, meaning they have three terms. We have a polynomial with three terms, and then this number up here is going to equal 1. We are going to practice factoring those today, or breaking them down into smaller pieces that if we multiply them back together, it will give us what we started with. So for the first question, it gives us a situation of quilt blocks again, and we're talking about blocks that are different lengths. So we're looking at rectangles this time instead of squares. So one side they want to be the standard length of x, and the other side they want to be 2 inches bigger. So for us, we want to have a length of x and a length of x, and then plus 2 more pieces on this side, plus 1 plus 1. And so what it looks like is we have 2 extra pieces on this side. And so those are the lengths. So we have a length of x plus 2 on top and a length of x on the side. And so if we multiply those together, we can look at it in this form. So one side times the other side, length times width. Or we can look at it as the sum of all of the areas of the inside pieces added together. So x times x is x squared, x times 1 is x times 1 is x. And so if I just add all of those pieces together, I can say I have x squared plus 2x's. And that is the area of my block. So now what I have to do is, given the inside area, so I have an x squared, I have 11 x blocks, and then I have 10 individual blocks. I have to rearrange those so that I can make a rectangle out of this. It doesn't have to be a perfect square this time, but it does have to be a rectangle. So we have to think about how to do that. So if I had actual blocks in front of me, maybe that would be a little bit easier for some of you. So think about if I had an x squared, I had 11 x blocks, and that's going to take a long time to write. So I'm going to just use lines for my 11 x blocks, 5, 6, 7, 8, 9, 10, 11. And then I have 10 individual blocks. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so I have to rearrange all of these so I can make a perfect rectangle. So I can't have any extras and I can't be short any. It has to make exactly one rectangle. So one way that we can do that is we can lay out a box as if we were multiplying two things together. And we know what the area on the inside is supposed to be. I know I'm supposed to have an x squared right here, and I know I have to have 10 right here. So we have to think of two numbers to go here and here. That is going to multiply to give us the 10, and they have to add together to give us our 11, because we know, I don't know how to split up the 11 yet. So one way to do this, so visually you can line them up and rearrange them as many times as you want. So what would end up happening is I would put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of my x's on one side and one of the x's over here, because then I would need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 blocks to make up that perfect rectangle. So that's what we're looking for. So in this case, I need 10 blocks on one side, 10 x blocks, and then 1 x block on the other side. So you can think about it numerically, or you can think about it visually, because now when I add those together, that would give me my 11x. So, but the deal is I have to do that such that I can figure out what the side lengths are. That is my goal. I want to know what the side lengths are. I already know what the whole area is. I want to know the side lengths. So visually, if you look at it here, you can see this has a length of x here and then 10 blocks over here. So x plus 10. And then the length over here is x, and then we have 1 block over here. So that would be x plus 1. Or if you can look at it in the box, like we were unmultiplying all of this, x is our GCF over here, and it looks like Just 1 is our GCF over here. Looking at the top row, x is our GCF again, and the bottom row, 10 is our GCF. And if I multiplied all that back together, then I would get all of those things. So 10 times x times x, so on and so forth. So x plus 1 times x plus 10 is my factored form of that original expression. So now we're going to try that again. I'm going to do it visually as if I had the blocks in front of me. So let's say I have an x squared, and then I have 7 blocks I have to rearrange, 7x blocks, and then I have 10 individual blocks. So let's see, I'm going to try, so I have to make up 10. I'm going to try, we're going to put 1, 2, 3, 4, and then 1, 2, 3. So I split up my 7 blocks, and then before I put my 10 blocks in, let's see if we can figure out, okay, how many would I need to fill that in and make a perfect rectangle? So I need 4 times 3, I would need 12, so that's not going to work. So let's try moving this over, putting that on that side. So I need 5 times 2, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, perfect. So that works out perfectly. So then my side length on top is x, and then I put 5 x blocks on that side. And then on the side, I have x plus 2. And again, you can check that. You can FOIL that back together and see if you got the right answer, if that gives you exactly what we had in the first place. So we want to look for some patterns. So these two numbers, like where do they come from? Like, do I have to draw the picture every time? And the answer is no. If we can come up with some patterns to find these numbers, then we'll be good to go. And we don't have to draw the picture every time. So how this works out is, if you notice, those two numbers, every time they multiply to give us our last number, our C number. So 2 times 5 is 10. And 1 times 10 also equals 10. So they multiply always to be C. And then how are they related to this number in the middle, the B? Because they both multiply to be 10, so how does that make the middle one different? And this time, it's the sum. If I add 5 and 2 together, that gives me the middle number. And if I add 1 and 10 together, that gives me the middle number of part B. So here's the rule. Please write this down. So the rule is that you're going to get two numbers that add to be B, and then they multiply to be C. And they have to multiply. And they actually have to multiply to be A times C. However, in the ones we're looking at today, our A is always going to be 1. So really for us, they multiply to be C. Okay, so this is one way that you can organize some things. So we're just going to practice thinking of numbers that make this work. So we want to come up with numbers that multiply to give you the top number. So they have to multiply to be this one, multiply to be this one, multiply to be this one. And then they have to add together to be the bottom number. So for us, they have to add to be this one. I'll put a plus sign down here so we remember this one is what they have to add to be. This they have to add to be, and this they have to add to be. Okay, so now let's come up with some numbers. So we need two numbers, and sometimes I make a list off to the side. So let's say, so 12, what are some numbers that multiply to be 12? I know I have 1 times 12, I know I have 2 times 6, I have 3 times 4, but which pair is the right pair? Because I need the pair that multiplies to be 12, but they also have to add together to be the bottom number, to be 7. So this time, 3 and 4 are the numbers that we need. Okay, so let's move over and try this one. So negative 40, they have to multiply to be negative 40. So we have 1 and 40, and again, one of them has to be negative. So 1 and 40, 40 is divisible by 2, so 2 times 20. 3 doesn't work. Let's try 4 and 10, negative 4 and 10. And you can stop as soon as you find a pair that adds together to be positive 6. And the negatives and positives do make a difference. So this is my pair this time. They multiply to be a negative number, and they add together to be positive 6. So go ahead and pause the video and go ahead and try these two questions. So they have to multiply to be the top number and add together to be the bottom number. So I'm going to make my list over here. 1 and 28, but again, one of them has to be negative. Okay, so it looks like negative 4 and 7 is very close to what I want it to be, but it's not quite, because when I add those together, that gives me a positive 3, and I want a negative 3. So really all I have to do is I'm going to use those numbers, however, I'm going to switch which one is negative, because that still multiplies to be a negative 28, but it adds together now to be a negative 3, which is what I want. And those negatives make a difference. It's so important. Okay, how'd you do on this one? So I have 1 and 16. Remember, one of them has to be negative. Okay, do any of those add together to be 0? And the answer is yes, 4 and negative 4. Perfect. So now we're going to use those in our factoring. And here's a reminder, as with every factoring problem, you should always look for the greatest common factor, GCF. That's always the number one thing to look for. So here are our steps, and we're going to look through these. So rearrange the quadratic, so make sure it's always written in this form with your x squared term first, your linear term second, and your constant at the end. And then we look for those two numbers that we just practiced finding. They have to multiply to give you a times c, and they have to add together to be b. So this step we might skip for today because we know a shortcut, because we are only doing trinomials today that multiply to be a times c. But I am going to do one practice with rewriting the middle term. We will do this a lot next time. And then factor by grouping. So that is something we already know how to do, but we're going to see if we can come up with a shortcut. So here we go, rearrange. So this already has x squared first, and then our x term, and then our constant. So we're good on step number 1. So what we need to come up with is two numbers that multiply to be negative 21. Remember, we're getting these numbers from over here. And it has to add together to be 4. So let's think. So we have 1 and 21. 3 and 7. So I think that's going to work out the best. However, it needs to add together to be a positive 4, multiply to be a negative. So those are the two numbers that we need. So step 3 is rewriting the middle term. So I'm going to split this up. Rewrite this whole thing, except the middle term is going to be broken up into those two numbers that I just found. So negative 3, but it's the x term, so they both get an x, and then 7. So negative 3x and 7x. If I combine those back together, I still have 4x. So I'm just rewriting. And then I can solve this by grouping. So remember your grouping. So we group, pull out the GCF, which is x over here. So we pull out an x. My GCF over here is 7. So I pull out a 7. Divide by 7. Don't forget you're dividing. And then I pull out the GCF from both sides, which is x minus 3. And then I'm left with x plus 7. So there we go. So can you see a shortcut? Can I jump straight from, can I skip any of these steps? And the answer is yes. When a equals 1, if you notice these two numbers that we found match these two numbers here at the very, very bottom. So once I get to these numbers right here, I can actually skip these two steps right here and skip all the way down to our final answer. But again, that only happens when this number up here, a, equals 1. So let's try that on the next one. So again, pause this video to try it yourself. And you have to remember which numbers are which. So they have to multiply to be 28 and add together to be negative 11. So multiply to be 28. We have 1 and 28, 2 and 14, 4 and 7, Okay, however, we have a conundrum. So these two look like they might be pretty close to what we need. However, if I add those together, I get positive 11. But do you remember what we can do is I can change those to negative. And if I change them both to negative, I still get a positive 28 when I multiply, and this time I get a negative 11 when I add. So remember, since a equals 1, this guy up here, I can skip all the way down to my final answer because I know this first term comes from doing x times x, and my other terms are going to come from those two numbers that I circled, so from negative 4 and negative 7. And there's my final answer. Next example. Okay, this is a little tricky because we have one where a is not equal to 1. However, do not forget to look at a GCF for this whole thing. Is there a number or a variable that I can divide all of these terms by? And the answer is yes. We have a GCF of 3. So if I pull out a 3, I'm left with x squared minus 3x plus 2. So I divided all of them by 3. So now I have this trinomial in the middle where a is equal to 1. So that is what I'm going to use my factoring trinomial method on. So they have to multiply to be positive 2, add together to be negative 3. So really my only options for multiplying to be positive 2 is 1 and 2. But they have to add together to be negative 3, and right now they add to be positive 3. So again, the trick is we change both of them to negative. So they still multiply to be a positive number and add together now to be a negative. Don't forget to keep your 3, so that's just going to come straight down. And then this is going to turn into, with our shortcut, we're just going to use those numbers we circled, negative 1 and negative 2. So there is our final answer. Over here, I'm going to rewrite this so that we have our x term. We're missing our middle term, so I'm going to actually fill that in with a 0x. So we don't have any, but I can represent that with a 0. So that means when I fill this out, we need two numbers that multiply to be negative 16 and add together to be 0. So looks like it's going to be 4 and negative 4. So I can jump to my final answer. X and x. When I multiply, that gives me the x squared. And then I use the positive 4 and negative 4. And it doesn't matter which one goes first. Just make sure you have both of those numbers in your final answer. Okay, try these last ones. Pause the video, try these last ones, and then I'll show you the final answer. Don't forget about the GCF. And remember on this one, we're looking for what times what gives me negative 25 and adds together to be 0 since we're missing our middle term. So we get negative 5 and positive 5. And here is the challenge. So try that one out, and the answer is written on the answer key that you can find on Canvas.